Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 9 of the 30-day LeetCode challenge, and the problem which has been given to us is the backspace string compare problem. So let's just go through the problem description. So given two strings s and t, return if they are equal when both are typed into empty text editors. A hash means a backspace character. So you've been given an example over here, and I'm assuming that you're going to be given two strings inside your arguments. And if you have s, which is represented like this, and t, which is represented like this, the way you sort of look at it is that if you type in a, b, and hash means a backspace, which means remove b, and then type c, so you have ac. Similarly, for T, if you go A, you put an A in your text editor, then D, then hash, which is a backspace, so that gets removed, and then C. So basically, this should output true, meaning that S and T both are equal as they both become AC. A few of the examples over here, you can pause this video and go through them. The link should be in the description below, so you can try to see the problem on your own and try solving it as well. There is a few ways of how you would want to solve this problem, and as you can see, since you are doing text editors, this problem becomes really easy because you don't really have that many constraints, to be honest. So if you think of a particular value as being a text editor, you could just think of it as an array of characters or basically a string, and you can keep on pushing values inside of that and work forward with that. There is a follow-up, and we'll try to solve the follow-up after we submitted the solution. So the idea behind how I'm going to go about it is that since right now, as of now, there are no space restrictions whatsoever, you have S and you have T. So I'm just going to make a separate list for S and a separate list for T. And what I'm going to do is I'm going to keep on appending the values until I encounter a hash. And whenever I encounter a hash, if there's a value which I can pop out, I will pop out that value. So a pop operation should be basically O of 1 because we're popping out the last value inside our temporary array. And basically we keep on moving forward with that. We'll just start with the base condition, which is just going to be, hey, if nothing has been given to us, we just return, well, we return false. I'm not ready to show whether this base condition is correct, but for now, let's just go with it. And I'm just going to create a few temporary arrays, and I'm just going to call them res s and res t. Again, the entire ideology behind this thing is just that we keep on pushing the values as we sort of move forward. So what we'll do is for each character in S, and we'll traverse through the S string first, try to push stuff inside this value, and then sort of move forward with the other temporary one. So for S in S, all we have to do is we just have to check whether S is a hash, and if S is a hash, then we need to check whether res has something inside of it. If it does not, then we don't perform any operations, and this is just a safety check so that we don't get any issues. But if there is, then we pop out the last value, which is the inside res, right? And otherwise, if S is not a hash, that means it's a character. So we just go ahead and append the character. So we just say res dot append and add it to the value. So a simple append operation works here. And since I'm doing this, let's do this properly. Let's make it a utility function, pass in s, pass in res, which is basically the temp. So let's just call it the temp, and work with that. So since we're doing this, let's just quickly go ahead and update the temp as well. And there we go. So we can call this function on rest d as well as the other one. So let's just go ahead and return. Actually, we don't need to return temp, to be honest, because it will get updated, but just for the sake of clarity, we're just going to do that. So res s is going to be equal to util of s and res s, which is basically the value, or we can just give a empty array over here as well. So that also works. Oops, I think I deleted this thing by mistake. Let's just go ahead and paste this again. And the same operation with t. So all that's happening over here is basically that we are maintaining a temporary res s and temporary res t. And all we need to do now is that since we have this value, we can basically just return whether res s and res t are equivalent to each other or not. Let's just go ahead and try to submit this solution. Hopefully this should run fine unless I have made some errors. So cool, this thing works. Let's just go ahead and submit this. Hopefully this should get submitted fine. I did not. Oh, okay. So what am I missing over here? Let's just quickly have a look at that. Oops, I can see what's going wrong. Um, this thing is just going to be some array. So let's just say array string and just put this thing over here. So I think this should run now. And awesome, you can see that the solution has been accepted. But let's go ahead and think about an actual interview scenario. So in an interview, what's going to happen is that you're going to be asked the follow-up question. And the follow-up question is, hey, you need to solve this in O of n, which we already achieved. We solved this in O of n in two passes in O of 2 into n, but still O of n. But the space complexity was O of n. Um, so how about we try to solve this in O of 1 space? Now, if you try to gain an intuition behind how you would try to solve this problem, the way I would approach this problem is that I see a lot of backspace operations happening, and most likely when we have operations like this, we want to do we want to use something like a two-pointer approach and keep on comparing the values as we sort of move forward. So we should have a ith index and jth index. So ith would be regarding the s string and jth will be the t string. And the entire process of handling this all these operations is just going to revolve around the fact that you are going to be iterating, or you're going to be getting the next value for I and j, and you're going to keep on comparing those values till you either hit the base condition, which is that you've traversed all the elements inside the character, or you have not done anything. um, but when you sort of try to think about it, the way I would approach this problem is a little bit different than how other people would. So the way I see this problem is that I want to do a reverse traversal, or I want to iterate um, backwards, which is right to left instead of left to right. And the reason for that is that whenever I encounter a hash character, I can maintain a skip and I can skip over all the other things. So if I have something like, if I go from right to left in this scenario where you see you have C, you compare C with C, that's fine. But when I encounter a hash, what I'm going to do is I'm going to count the number of hashes which I'm going to get, and I'm going to skip over all the items which are there within that hash till hash becomes 0. Or basically count the number of backspaces which are there and then go backwards from there. I know, like, I'm not really doing justice to explain this problem, but just bear with me for a few seconds, and most likely I'll be able to show you how you guys want to like try to solve this problem. So what I'm going to do is I'm going to be good about this. I'm going to call a next function, and this next function is just going to take a string and the ith or the jth element. It doesn't really matter. This is basically the index. And what this will help me deduce is that from S, wherever I am presently, what's the next value that I need to go to? And that's basically like how many hops should I take if I need to take any hops. So what we can do is we can maintain something like a distance. So we'll just do d equal to 0, which is just going to be the number of skips or hops that we want to take. And all we need to do is we just need to run a while loop. And the while loop is going to be like, hey, if I is greater than equal to 0, and also if we have si which is equal to hash, then we need to increment the d. Otherwise, we don't want to increment the d, we want to decrement the d. And we keep on doing that while also decrementing the value of I. So if you didn't get to know what I'm talking about, all I'm going to do is I'm going to start with this simple operation. So I'm just going to iterate reversively uh, and go backwards. So I'm just decrementing the value of I, and I'm going to return I. It's pretty straightforward. The conditions which I'm going to place in are actually more important. So I'm going to say, hey, if s of I, wherever I is presently, is equal to hash, or d is greater than 0. So if d is greater than 0, that means I need to do a skip. So I do a skip and I decrement the skip, right? So pretty straightforward about that thing. And if I have si, which is already a hash, I need to increment the skip. So Let's just do that. Let's do si is equal to hash and increment the skip that we're going to put in. Otherwise, you decrement the skip, and I keeps on getting decremented, and basically the next value that you're going to get is going to be the next value after you've performed all the skips. Um, and now since we sort of made this a function, we can use this over and over again. So I'm not ready to show whether this is going to work properly or not. I hope it will, but let's just try it out because this is the first time I'm trying to solve this problem in that way. So what we're going to do is we're going to initialize I, and we're going to say, hey, get me the next value of s where the index is at the last element. And similarly, we do the same thing with j, but with the string t. So this should ideally get us the next value, and we're going to use this extensively. So all we need to do now is we just need to do another while loop just to check all the ith and jth values. So we'll just put a few checks, which is going to be, hey, if I is greater than 0 and j is greater than equal to 0 and si is equal to tj. So you keep on iterating through the loop, um, and the return statement should be that if I is equal to 1 and j is equal to 1, we know that the reason why this thing broke off, this loop broke off, is because not because of si and tj not being equal, but because all the iterations had already happened. So let's just put a quick check. Let's say I is equal to 1, or let's just say less than 0 and j is less than 0. And over here, what I'm going to do is I'm just going to place in my ith and jth value. So basically the function that we already defined, which can find the next value, we can utilize that and find the next value which we have in place. I'm just going through this. I see a problem. Let me just fix that, which is pretty straightforward. And I think this should work. Not that complicated. Let's just go ahead and run this. Hopefully this should run fine. Unfortunately, the editor sort of just is taking a lot of time. So time limit exceeded, that sort of makes sense because it was taking so much time. So let's just evaluate where exactly did we go wrong. So you have t, which is the correct value. Oh, I see what's going on. Yeah, so this was incorrect. We need to make sure that we're going to the next value, which is I minus 1 and j minus 1, not length of s minus 1. That's pretty dumb. Simple copy paste mistake. And cool, this thing ran and it's running fine. Let's just go ahead and submit this. Hopefully this should run fine as well. And awesome. And again, like the way I'm trying to look at this problem is basically like when I have an intuition on how I'm going to solve it without any memory complications, and I have no worries whatsoever. I'm just going to brute force the solution. I sort of already saw this next function coming into play because I knew for a fact that I need to do all the hops. And in an interview, you have to be aware of all these, questions coming in, and yeah, that's basically it. So I'll just do a quick summary and then we'll end this video. So a quick summary is we define the next function which can find us the next value which we have at an index I and tells us how many hops we need to take. So whatever's the next valid character, and it just returns that index. Um, and that function is defined over here, and we leverage that function to iterate in a right to left manner instead of a left to right manner, so that we go from the last element till the first element, and we keep on iterating it till we either we go through all the elements inside the string, or we break it apart because some value is not equal to each other. And the return statement is basically helping us deduce the Boolean value that we need to return. And awesome, this is basically it for today's video. If you didn't understand something, I can understand like some things are a little bit more complicated. I was trying to solve this problem for the first time, so I might have messed up a little bit. But if there's something that you didn't understand, leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here and we would love to have you on board with us. If you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.